Two molecules, one formula. Same or different? That's the heart of isomers. So what exactly makes molecules isomers? In this video, you'll learn the two big families: structural or constitutional isomers and stereoisomers, plus how to spot enantiomers, diastereomers, as well as cis-trans and EZ pairs. Isomers share the same molecular formula, but differ in how atoms are arranged. Either the bonds change or the 3D orientation does. Structural isomers change connectivity. Butane and isobutane are both C4H10, but the carbon skeleton is connected differently. Ethanol and dimethyl ether are both C2H6O, yet their bonds form different functional groups, so their properties differ. Rotating or flipping a model in space doesn't create a new molecule. Changing bonds does. Stereoisomers keep connectivity the same, but change 3D arrangement, like left and right gloves cut from the same pattern. Let's take a look at enantiomers. They are non-superimposable mirror images. They usually arise from a chiral center, a carbon attached to 4 different groups. Invert all chiral centers, and you get the enantiomer. Diastereomers are stereoisomers that are not mirror images. With multiple chiral centers, flipping only some creates diastereomers. Flipping all of them gives the enantiomer. Now, let's examine meso compounds. They contain chiral centers, but an internal mirror plane makes the whole molecule achiral. Around double bonds and rings, rotation is locked. Substituents can be on the same side or cis, or opposite sides or trans. For more complex cases, we use EZ based on substituent priority. So far, we've covered 2 big categories: structural isomers, different connectivity; stereoisomers, same connectivity, different 3D; and within stereoisomers, enantiomers, diastereomers, and cis-trans, or EZ. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, test yourself. Same skeleton, only one chiral center flipped. That makes a diastereomer. If both centers flipped, that pair would be enantiomers. Also, avoid these pitfalls when comparing molecules. First, don't call cis-trans structural. Structural isomers differ in connectivity, while cis-trans differ only in 3D arrangement around a double bond or ring. Second, don't confuse a rotated picture for a new molecule. If the connectivity is the same, it's still the same molecule. So here's the checklist. Isomers share a formula. Structural isomers change connectivity. Stereoisomers keep connectivity, but rearrange in 3D into enantiomers, diastereomers, and cis-trans, or EZ. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.